All right. Okay. Uh, this is a 2016 physics paper, and we'll be going over the MCQs first. So the first MCQ, which asks the SI unit used to measure the activity uh, of a radioactive source is. All right. The first answer they've given is, let's write this down. Is the corral. I'll use white color. It's much easier. All right. Second one is gray. Third one is joule per becquerel. Fourth one refers to have per becquerel. The fifth one is watt. Right. So before we go to these units, I'll give you a bit of understanding what radioactivity and what activity is. So radioactivity, it's a process which is actually loss of mass and energy when an atom or a nucleus is unstable. So unstable means it has a bit of an unproportionate value when it comes to the number of neutrons and number of protons in the nucleus. So this, because of this unstable nature, all this intermolecular structure, it becomes really unstable. So these interactions and everything, it tends to be stable, right? So what they try to do is they try to emit something. They try to let me use another color so that it's much more colorful to you. It tends to emit some kind of where's the color? Let's go. Yeah, tend to emit some kind of a radiation to lose its energy and mass. Alright, so that's what we call the radioactivity. So this radioactivity and the activity is the measure of this radioactive decay. The decay, as in this radioactive decay, can happen in three ways, which is the alpha emission, beta emission, and gamma emission. If you want more knowledge on that, you can always go and search about this. It's really interesting. So how many of these emissions has happened per second? This is alpha, beta, and gamma. And there's another emission called neutrino emission, which is not really important at this stage, but if you are interested, you can always search about that. And so how many of these emissions happen per second? That's what we define as the activity of a radioactive sample. So this, okay, for the SI unit to be determined, this SI unit was named after a French physicist who is a famous one known as Henry Becquerel, who discovers the first presence of radioactivity. So he this radioactivity was named after him, as in the activity of a sample. So before I go towards this Becquerel, which I have already marked it red, alright, I'll just give you a bit of understanding of what these other four units are. This is just for knowledge. You don't need to actually memorize this stuff, but it's always good to know something extra, right? So I'll just refer to what this what's gray. Alright, what is gray? Gray is actually not an SI unit at all. Gray is a measure of dose. Dose as in how much of radiation. As, let's say you have some kind of a sample just next to it, alright? So this guy emits a lot of energy and so many these kind of stuff. And this small sample get attacked by this stuff. Right? This could be an eraser, this could be some kind of a pencil, or this could be even a person. Yeah, because you can always be near a radioactive sample. So how much of this radiation is being absorbed by this bugger over here? All right. So it's actually measured. The gray can be defined in the simple terms as how much of energy is absorbed, which is like 1 joule of radiation energy per kilogram of the matter, of the mass of that sample. Alright, so that is actually what's defined as gray. So it's actually doesn't have anything to do with the activity at all. It's actually a measure of the dose received. So we can actually straight away omit this guy from the equation. We don't even need to consider that anymore. Alright, so I'll go with, let's say, the blue color for joule per becquerel. Joule per becquerel, this is really interesting. This per becquerel is actually, as I said before, it's a number of disintegrations per second. So it means number per second, yeah, right? So number is not a unit at all. I'm just using it just to give an idea. So it's actually per second. So joule per becquerel is like a joule divided by what is number per second, yeah. All right, so what happens is like it becomes like joule seconds over here. Joule seconds doesn't have anything to do with activity at all, but joule second does have a meaning when you go to physics, or when you go to studies in terms of physics or nuclear physics. So you'll get this unit. It is actually a measure of action, but if it's not relevant to you at this time, this time period. But if you're interested, you can always think about the Planck constant, which is really famous one. Its unit is joule second. It does refer to something, but yeah, it doesn't have anything to do with radioactivity, as in the activity of a sample. So per second, as I said here, so since becquerel refers to number per second, or there's another color, let's see what let's go with a bit of a, yeah, let's go with purple. So per becquerel, so number per second, per means like the reciprocal, yeah, so 1 over number per second. So this guy becomes second per number, yeah. So what does this mean? A second per number. It doesn't. It's like the quite opposite of what we want. It's like it's not the number of integration happen per second, but how much of time taken to happen one disintegration, which is really interesting to think about, but it doesn't have much to do with activity at all. So we can omit all these three people from here as units. I'm sorry. So alright, the fifth one, servot. This one is really interesting. Servot is actually related to this guy, servot and Gray. Actually, the servot is the SI unit of dose, so we can say it doesn't have anything to do with activity as well. But servot is actually how you measure the dose in terms of SI unit. Uh, so since it doesn't have anything to do with what you call the activity, we can actually omit this. But to give a bit of understanding about servot is used to measure a lot of stuff like equivalent dose, effective dose, committed dose. So this dose is really important when it comes to the biological measurements, like how much of let's say a person who works at a nuclear plant, he can get affected by this dose a lot, right? So they need to constantly measure how much is absorbed by this person. So to know that, we use this unit and this derived unit as well, but as SI unit, the standard one, we use this one. So since all these four are wrong, I just give this description just to give a theoretical understanding of what these stuff are. So gonna straight away say this becquerel is the correct answer. So yeah, that's the correct answer for the first MCQ, which is becquerel. And yeah, I hope you found this video intriguing and interesting, and I hope to see you in the next video. Thank you very much.